computer. So we are recording also. Share screen, Microsoft PowerPoint, and then share. Do you get this screen?
Yes, sir.
Yes, sir.
Okay. So this is what was the last we shared. Let me take here. Yes. Structure of maltose. Now, when you see the structure of maltose, okay, maltose structure is this C1 of 1 glucose is linked to C4 of second glucose, but in second glucose, this anomeric OH group is free. As a result, what happens? This will be in two forms. That means two anomeric forms, alpha maltose and beta maltose, where this OH, anomeric OH group will have two different positions. For alpha, this OH will be down in Howard projection, and for beta, this OH group will be up. But in solution, they will pass on to one another through this open chain form. But open chain form only in this part of the molecule, this glucose molecule, not here. This will be remain always alpha. This alpha, because C1 of this alpha, this is the alpha C1 of this glucose, which is linked to the C4 of the second glucose. So this is what is the alpha here. So this glucose will be there. So when you dissolve this alpha maltose, it comes to open chain. When it then open chain again closes to give you ring chain, but this time you will be getting both alpha maltose as well as beta maltose. So there will be an equilibrium mixture of the two, and that is responsible for the mutual rotation of this. And as this aldehyde group is there, so it will show the reduction property. It will show formation of acetone. It will be reduced to alcoholic group, it will be oxidized to acidic group. So all the properties associated with the aldehyde group will be there. Also at the same time, so all the reactions that we have taken earlier, now you can take them with your. But what will be the conformational structure? Conformational structure is important. You know the glucose conformational structure. For beta glucose, all the OH groups are in equatorial positions. You know that one. So the conformational structure is this one. So this is the glucose where this is C1, C2, C3, C4, C5, and C6. This is C6. So this, all of them, they are in equatorial position. Already you know that one. But this anomeric OH group is in alpha. So alpha, this anomeric OH group will be in the axial position here, but linked to the C4 of the second glucose. The second glucose, the C4 was in the equatorial, so that way it will look appear in this equatorial position. And but C1, again C1 will be free OH, so I am not writing any particular alpha or beta. I am writing H and OH, so that when it is alpha, this OH group will be here. When it is beta, the OH group will be here. So that way we have this. Yes, somebody, I think that some sound is coming, extra sound. So you keep your this what is called microphone mute. Now we go to the second molecule, that is sucrose. What is sucrose? Sucrose is our table sugar, the sugar that we take. What is the source of this sugar? How do you get in nature? Yes, somebody tell.
Sugar cane.
Sugar cane. Yes, that is the main source, but is there any other source other than sugar cane? Beet. You know what is beet? That vegetable pink colored vegetable, dark pink, that contains lot of sucrose. But then the beet that we get in India or in our part, that does not have that much of sugar. For sugar beet, it is something. It looks appears as white beet, white, whitish in color. So that one, it is grown in some part of the world, that especially Russia. They get quite a good amount of their sugar, that is from beet, sugar beet. And the sugar industry is a big industry all over the world. And once that for sugarcane cultivation, Britishers took away so many Indian people, and they had taken them as forced labor and gone to places like now what is called Mauritius and some other island countries like that. So they have grown sugar cane, and the farmers, they were the Britishers, but their laborers were Indian origin, African origin, that type of thing. So that those islands also got inhabited by Indian people. Now some of these countries have their prime ministers and the head of the state of Indian origin. So you know that history. So actually, what is your interest on history? Yes, somebody tell. What is your interest on history? In history, interest in history. Echo, hello, huh? Do you like history or you don't like history? Huh? Nobody responding anything. History is very, very important. Of course, as a student, I didn't like history much, but now I find it has to be studied, and the teacher has to make the subject interesting. History is not just remembering some names of some kings and emperors and their battles and all. That it tells about the society also. Okay, let us come to sucrose, the sugar that we take, uh, which is the major sweetening agent for our for us. At the same time, the sugar is also a health problem for many people, those who have got uh, metabolic intolerance of glucose. That condition is called diabetes. Okay, let us see what about glue. We have to, because we have to focus on structure. That's once we know the structure, we know it's all the reactions and other things can be understood from there. So as usual, molecular formula is C12H22O11 and obtained by elemental analysis, percentage composition, and molecular weight determination. So this is what is C12H20. All disaccharides of hexose will have the molecular formula C12H22O11 formed by condensation of two monosaccharide. Monosaccharide is C6H12O6, monosaccharide of uh, hexose, monosaccharide, aldohexose or ketohexose. They will have the same molecular formula C6H12O6. And two of them, when condensed, there will be an elimination of water. So that water is going out from there and we get C22O11. Next, we come to undergo some reactions. From the reactions, we can know what is the nature of the molecule. So these are the sucrose. We carry out these reactions. Number one, hydrolysis with water. So we get glucose and fructose. Now, when we write here simply glucose and fructose. When the analysis was done, it was not that simple. We have to isolate this then identify each one what it is. And it is also concentration was found out, and it is found to be equimolecular quantity. So if we have if we take one equivalent of sucrose, we'll get one equivalent of glucose and one equivalent of fructose. But other reactions, then it was studied for other reactions. So, studied with Fehling solution and Tollens reagent. It was found that it does not reduce, does not form osazole, does not form glycosides when treated with alcohol in presence of acid. So in case of maltose, will form glycoside when treated with methanol and HCl as catalyst. We'll get alpha methyl maltoside and beta methyl maltoside, isn't it? But here we don't get anything like that. And also it does not exhibit mutations. So these are the properties that we get. Now, what is this property tells us, all these reactions tells us, gives us some information about the molecule. One information that we get from here, can you let me see what are the different information we get from here. Somebody tell. Don't pinpoint anybody. You just come volunteer and tell what it is. Which properties, what type of information we get about the structure of the molecule? Hmm? Yes, tell me, quick.
It doesn't have free oxygen or
Free, what? Does not
L
have free what?
L OH group.
There are
It
so
has
many.
OH group, yes.
OH group means what type of OH group you have to
In the
specify?
anomeric carbon.
Anomeric carbon. What is the first information we get? First information we get is that what is called, it is made up of these two molecules. One is glucose, the other one is fructose. And it does not reduce Fehling and Tollens. That itself will tell, it does not form osazone, does not give meter rotation. This tells about that, because these properties were associated with the anomeric OH group. Anomeric OH group which was there, which was actually, ultimately this one gives us an aldehyde group and an alcohol, that alcohol that was there. That is the property. After we, so this aldehyde group is not going to come. If it is, that means if it is not showing reduction, that means this aldehyde group is not present there. As a result, uh, this can happen only when this anomeric OH group in glucose and also in fructose are blocked. And this blocking can happen only when this condensation between glucose and fructose will take place between the anomeric OH group of each other. That is the information. So this information that we get, let us see. This shows that sucrose is made up of, one is D-glucose and D-fructose, D minus fructose. Remember, glucose is dextrorotatory, but fructose is levorotatory. So D minus fructose, and does not contain free carbonyl group. This is another information. And third information, must be linked through glycosidic linkage. This glycosidic link, this sorry, must be linked through glycosidic linkage of each other. And what are the glycosidic carbon atom? That is C1 of glucose and C2 of fructose. So this is the information that we get from here. Okay. So this is comparatively simple compared to your. So C1 of glucose is linked to C2 of fructose, but that is one information we are getting indirectly that information, but we have to prove it also. How do we prove? The linkage between the glucose and between glucose and fructose are also shown by the following experiment. What is the experiment? We do this experiment. What is done here? Sucrose is taken. Sucrose is taken. It is treated with dimethyl sulfate. What is dimethyl sulfate? It picks up, it does a methylation of a free OH group. So we get an octa-O-methyl fructose. What is dimethyl sulfate? Formula for dimethyl sulfate? You write down, all of you write down dimethyl sulfate. The structure for dimethyl sulfate, not formula. Formula is this one, Me2SO4. But what is the structure of dimethyl sulfate? Sulfur is at the. So dimethyl sulfate is a derivative of sulfuric acid. What is sulfuric acid? S double bond O, then again S double bond O, then sulfuric acid will have two OH group, but here it will be two. This H will be replaced by methyl group. OH. So this is your dimethyl sulfate. As a result, what is happening to this methyl group? Methyl group is what? Positive or negative? Methyl group is positively polarized or negatively polarized?
Positively polarized.
It is positively polarized because oxygen is there. So oxygen will pull electrons. So this is delta positive and oxygen will be delta negative. As a result, any alcohol, suppose we have alcohol here, ROH, this lone pair, but we are using sodium hydroxide. So there will be little bit of this H of alcohol will be what is called sodium hydroxide will pick up a small quantity of this. Equilibrium will be to ROH from the, but this will become little bit RO minus. So this will pick up this methyl, so we get ROMe. So that is what is the mechanism of this methylation of methylation of OH group. So when this all the free OH group which will be there will be methylated. So we get octa-O-methyl sucrose. Then it is hydrolyzed. When we hydrolyze, it is that group which is connecting the two sugars. One is glucose, another one is fructose. So that connecting point, this hydrolysis will happen, H and OH mechanism will be there. So you get one OH group free here and another OH group connected to fructose will be free. So what we get here, the one methylated group will be 2, 3, 4, 6 tetra-O-methyl glucopyranose. And this one is 1, 3, 4, 6 tetra-O-methyl fructofuranose. It is found to be 5-membered ring. It's found to be 5-membered ring. So let us see the structure. Now, structure of this one is this. Just see. Yeah. You see here. This is 1. There is no OMe. 2. There is OMe. 3. There is OMe. 4. There is OMe. And 6. There is OMe. And in 1 there is no OMe. It has become OH. It has become OH. And this is the part obtained from glucose. So we get 2, 3, 4, 6 tetra-methyl glucose, and from here we get 1, 3, 4, 6 tetra-methyl fructofuranose. That means it is 5-membered ring. So one, but one, again, I'm not writing here. Here also, I'm not writing this specific position of this OH because it is both of them will be there, alpha as well as beta. So I'm writing by this sign. So this practice you should do. You should not only write, if you write here, that means as if only beta glucose is formed. Not both alpha and beta will be here. So that concept you should have. Here it will be OH and CH2 O methyl. The carbon number 1 was free in that sucrose. OH group was free, so that was methylated. This is methylated to 3. 4 is methylated. 5 is not having does not have any OH group, so it was not methylated. 6 is methylated. So 1, 3, 4, 6 methylated. Then what we find here, there is a free OH group has appeared in carbon number 1, and there is a free OH group has appeared in carbon number 2 of fructose and carbon number 1 of glucose. That means the connecting carbon between the two sugars is glucose is C1 and fructose is C2. Yes or no? Yes or no? Hello?
Yes, sir.
Yes. You should look, it should look that you are alive. Huh? So that is what. So we are getting the connecting carbon atom between the two, C1 in glucose and C2. So what is the next one is this. The result shows that glucose is present in a 6-membered ring, and fructose is present in 5-membered ring. So these are two information, and also C1 of glucose is linked to C2 of fructose. Why? The free OH group appears in that position where there is hydrolysis, where the hydrolysis has happened, and hydrolysis will take place in that position which connects the two groups. That means C1 of glucose is linked to C2 of fructose. Yes. Now, what is the next stage of the structure elucidation? Next stage, what it is? Tell me. What is the next stage? What other information we have to get? We are almost close to your structure of uh, sucrose.
Glycosidic linkage.
That is glycosidic linkage, because C1 of glucose is an anomeric carbon. Once it is anomeric carbon, it is going to be an alpha or beta. The other one is both of them. In C2 for fructose is also anomeric OH group. And this anomeric OH group bonding with another alcohol, that is called a glycoside. So what it is, basically it is a glycoside of glucose and also a glycoside of fructose. So this is a special case. Just see. So we have to come to glycosidic linkage. How do we determine glycosidic linkage? What is the method you adopted? Yes. What is the method? Enzyme hydrolysis. So we take specific enzyme which was known to hydrolyze alpha and which is known to hydrolyze beta. So sucrose is hydrolyzed by maltase. You see here, the first one is maltase, an enzyme specific for hydrolyzing alpha glucoside. Now you see, it's not all type of glycoside, it is glucoside. That means on the glucose, alpha glucoside is hydrolyzed by maltase. And that is what is also present in starch. So therefore, sucrose is a alpha glucoside. That information also we are getting. Also, sucrose is hydrolyzed by invertase, another enzyme. An enzyme specific for hydrolyzing beta fructofuranoside. You see, it will be beta, but it has to be fructose, and that fructose also has to be in 5-membered ring form. Only then it hydrolyzes, invertase hydrolyzes that type of sugars, not others. So invertase, you have come across invertase in some other connection. Do you remember where you have come across invertase? Hello? Hmm? In what connection you have come across invertase? Anybody? Hello?
Yes, sir.
Where you have come across?
Sir, what is the question?
The question is invertase as an enzyme you have come across in some other connection, some other chapter, some other topic. Which is that? Nobody remembers?
Sorry, sir, don't remember.
Do you remember fermentation of alcohol fermentation? Alcohol fermentation from molasses. Molasses is that is the that brown liquid that is left out after extraction of sugar in the sugar factories. That is molasses, and that molasses contains sucrose. And what is there is a microorganism used to carry out this fermentation. What is that microorganism? You take yeast, but yeast first stage of breakdown of sucrose is that yeast converts your sucrose into glucose and fructose. That time they had enzyme that was used that gets involved is your invertase. Invertase. And why the name invertase is there, that also we'll see this one now. Why the name is invertase. Where from this name has come. Anybody any idea why this name invertase is there?
Sir, sucrose is invert sugar.
Sucrose is inverted sugar. No, that is not correct. But you are approaching that side, but it is not. Sucrose is not inverted sugar.
So hydrolysis of sugar.
Uh, yes, hydrolysis of sugar happens what? What does it do? Okay, yes, okay, we are getting that. You are getting that point. We'll discuss that. So, so these two enzymes tells us that one is alpha glucosidic linkage and another is beta fructofuranosydic linkage. So that much. So therefore, your sucrose is an alpha. Sorry, sucrose. My pen is not. I'm not very comfortable with this pen. Alpha is a alpha. Sucrose is a alpha glucoside and also it is a beta D fructoside. Now the structure is clear now. You have to link these two molecules together from C1 of glucose to C2 of fructose, but through alpha glucoside and beta fructoside. So the structure is given as this one. Just see. This is your glucose, right, left, right, right. Glucose, this is C1. The OH group, this is your the alpha OH. So OH was here. Therefore, second one, fructose, this is your C2. The C1 must be here. This is C1, then C2, C3, C4, C5, C6. So C2, but C2 has to be from the top position. because beta, so that is your, so the condensation OH and OH condensation gives you this oxygen. So that becomes your sucrose. Fischer projection also we can write it like this. This is your Fischer projection, alpha glucose, and this is your beta fructose. Beta will be left hand side. Bia, beta, you remember that. So that becomes the structure. So it is very simple compared to your maltose, but both I don't say maltose is anything difficult, but then you have to know those key points. Key points. I think we are. So that's all. So that is the structure. Now let us see some of the important some reactions of sucrose. One is you know it is nothing has to be told that whether it is soluble or insoluble in water. But it is melting point is 180 soluble in water. And it is dextrorotatory and its specific rotation is plus. It is a dextrorotatory compound. Sucrose is a dextrorotatory compound and specific rotation is compound. Now, sugar is a very important item. Sucrose is very important item in our food, day-to-day food, and also food industry, sweet food, and all these things. And some of you, do you prepare sometimes some dish with sugar, doing something, especially these ladies? But why ladies? Anybody can be. There are more male cooks in food industry than female cooks. The male cooks are number is much larger compared to female cooks. So it's not that is a female domination in cooking, but household cooking is still dominated by females. Anyway, tell anybody has prepared anything with sugar with some special type. Not that you just mix sugar and get sweet and all these things. Anything that you can then other than this sweetening in a conventional sweetening way, sweetening, you do anything else with sugar. Huh? Or nobody is interested in cooking or helping your mother.
Sir, sugar syrup.
Sugar
Sugar
syrup.
syrup.
Sugar
Yes,
syrup
sir.
sugar syrup is also a sweetening
No,
agent.
no, sir. For this one, for making rasgulla and all that one.
So no, that is sugar syrup. Sugar syrup is
Yeah.
also nothing but sweet to make it sweet. That's all. Anything. Do you know something called caramel? Making caramel?
Yeah. Yes, sir. I was. Yeah, but I explained it wrong, sir. I was talking about that only.
Yes, it
It's
is
caramel. Yes.
caramel. Making caramel. What is caramel? How do you make it? Caramel, you melt sugar. Sugar will melt at 180 degree. Remember, just see, it is 180 degree. So it's not very high temperature. But if you heat it little more, you will find that that sugar is becoming brown. But after sugar has just become brown, you remove the flame. You remove the flame, let it cool down, and you will get a thick brown liquid, syrupy liquid. So that is your caramel. When it solidifies, it gives a something. That has got is not a charred sugar. It is not charred. It is not burnt out, but it is converted to something different and having some different flavor, different color. So that caramel is used in for different thing in your preparation. There is a caramel dessert is there. One can prepare egg dessert with caramel. There are, nowadays I watch this YouTubes with this food, but though I have never experienced or never done it myself. But I like to watch this what is called videos. So this is what is caramel. So sorry. Oh my God, what is it? Oh, what has happened? Okay. Acha. Now another important property is hydrolysis. And this hydrolysis is also known as inversion of sucrose. Inversion of sucrose. And how do we do it? We can do it by using this. Hydrolysis can be done by sucrose. When you hydrolyze it, we can do hydrolysis by doing water in presence of acid. That will give you glucose and fructose equimolecular quantities, one equivalent and one equivalent. Or we can enzyme. But one interesting things happen here. You see, sucrose, which is the starting material, it is a dextrorotatory compound. But after you have hydrolyzed, what you are getting? You are getting 1 mole of one equivalent of glucose and one equivalent of fructose. But what is the specific rotation of glucose? It is plus 52 degree. Glucose is plus 52 degree, but fructose is minus 92 degree. It is a laboratory with specific rotation minus and 1. So what is the net specific rotation? It becomes minus 40. And when it is minus means it is laboratory. So a dextrorotatory compound has become laboratory, and the process is hydrolysis. So hydrolysis is also known as inversion of sugar. So inversion of sugar is nothing but hydrolysis of sugar. As sugar means sucrose. So that is. And that is why that name enzyme is invertase, because this enzyme is invertase. And invertase is because it is inverting this sugar. So that enzyme, which is it is an inverting, it is inverting this particular, inverting in terms of your specific rotation from dextrose, it has become levorotatory from dextro to levo. So that enzyme is named as invertase. And this. Now, which is termed as invert sugar? Now you tell me. There is one term used called invert sugar. What you will call an invert sugar? You will call invert sugar a sucrose and invert sugar, or glucose and invert sugar, fructose and invert sugar. What? Which one you can be termed as invert sugar? Come on, quick. We are getting time is getting over. Yes?
Sucrose, sir. Sucrose.
Sucrose will be termed as invert sugar. No, sucrose is dextrorotatory. Huh? Which one you will call invert sugar? Now, wait. Invert sugar is an mixture of equimolecular mixture of glucose and fructose is termed as invert sugar. From sugar, you are getting invert sugar because this equal.
Sir, honey.
Yes. Yes.
Sir, honey is also known as invert sugar.
No, remember, wait. Honey is something different. Honey contains maximum quantity of fructose. And which is the sweetest sugar? Because sweetness is also another parameter connected with sugar. Which is the sweetest sugar of all these sugars that we are studying? Huh? Yes?
The sweetest sugar is elite.
Elite.
Yes, sir.
No, we are not talking of sugar derivatives, remember. It is sugar, simple sugar. There are so many derivatives prepared and they are sweeter. Okay, that is different. That is artificial. Natural. Fructose. Fructose is the sweetest of all sugar. Now, if we take the standard sucrose, because for us, for common man, sweet sugar means it is sucrose, means stable sugar. If you take this sucrose sweetness as 100, fructose is 173. That means it is 70% more sweeter than your sugar. And your glucose is less sweeter compared to your sucrose also. If it is 100, this glucose is 70, but fructose is 170. Now, I am talking here invert sugar. This equal mixture of glucose and fructose is termed as invert sugar because here you have a net laboratory devolution in this mixture. So that is this is sugar, this is invert sugar, equal mixture of this. So hydrolysis is known as inversion of sugar, sucrose. Remember that. And these are some of the reactions. Yes.
So, but the equal mixture of glucose and fructose will be sucrose only.
No. How can you say that is sucrose when they are connected together? No. Only that
Yes.
is sucrose. Huh? If they are joined together. Now it is they are separated, no?
Oh, separate. Oh, okay.
They are not connected anymore. They are independent molecules now, glucose and fructose.
Okay.
Isn't it? You can separate glucose and but sucrose, you cannot separate glucose and fructose. Once you do hydrolysis, after that you can separate because they become independent molecules.
Yes.
Got the point?
Yes.
Okay. So this is a very important term associated, remember. And now you see here, this is sucrose. If I heat it, this is your caramel that way. Heat is, you see, we should not heat too much. 210, melting point is 180 degree, 210. And that way brown amorphous solid, that is called caramel. And that is used in food industry very much. Then acetylation, as usual, those free OH group will be, free OH group will be acetylated, others will not be. Methylation, all the free methyl group will be acetylated. If you do reduction, sorbitol and mannitol will be getting, it will be splitting into here, and glucose will be, all the aldehyde group will be converted into OH group, OH group, CH2H group, and here the ketonic group also will be converted. But ketonic group converted will give two isomeric form. One will be sorbitol, another one will be mannitol. Anyway, you can read it from there. So with this, we finish this one. I am not going to do the structure of lactose. Why I will not be doing? Just see. If I end up here, you see here. Now, I see we have to switch over. I'll give a question here. You have to solve the question related to this. This carbohydrate up to disaccharide. All the questions that I'll forward. And maltose structure, lactose structure, I am not doing it because maltose and lactose, they are similar, very much similar, except here this is, one is galactose and the other one is glucose. Yeah, one is glucose and other one is also glucose. Glycosidic linkage is alpha, here the glycosidic linkage is beta. So that much, but it is also part of your syllabus. So you have to read on your own and there is nothing difficult. Now, with this, let me come back. I stop sharing. You just see. Now what I'll do, next class, okay, we'll be still with the carbohydrate chemistry, because I'll give a questionnaire. You have to solve that one. We'll discuss the questions and then we'll wind up this part of the carbohydrate chemistry. Polysaccharide, we'll be doing it later on. Next, after that, maybe after Puja, we'll start with Puja. You'll be having 2-3 days vacations, only 2-3 or maybe 2-3-4 according to the notice that we will receive. We'll start with what is called the other topic, that is not energy of this carbohydrate. We'll come back to this one later on. That is your perisaccharide. So we'll start with that one, and pericyclic being a new topic, completely new to you. Undergraduate you have done, but I don't think you have really understood that one. But here again, that is a topic. If you are attentive to class, you will understand. If you are not attending the classes, you will not understand it. I'm just telling. Now tell me, give me one feedback. What about your carbohydrate chemistry now? Is it now you can now you have understood it or not? Yes or no? Yes. Hello. Tell me something, or you have not understood anything.
Yes, sir, understood.
Huh? Only 1 or 2% should not do. Huh?
Yes, sir.
Yes, sir. Oh, baby Singha. Let me see your face. Baby Singha. Hmm? You getting my voice? Hello, or you are not there? Somebody else is handling your system. Baby? Oh, you are
Sir,
here.
I am there.
Oh, you are there. You were listening, huh?
Yes, sir.
Okay, okay. Any problem understanding this topic?
No, sir.
No. Okay. Again, today I may upload. Okay, I will. Oh, sorry. One more thing left out. Very important. We'll be doing this. What is called another topic before we go to pericyclic is your next day. I have to do it. That is paraodic acid oxidation to determine the ring size of this. We are accepting that glucose is 6-membered, fructose is 5-membered, but we should not accept it blindly. We have to experimentally determine it. That is, so that topic. After that, we'll go to pericyclic. Okay, so with this, we end our class. This platform has to be released for, I think, another teacher. So, okay, all the best.
Thank you, sir.
Yes, sir.
Thank you, sir.
Okay, bye.